Hi, so the goal for this chapter is to show you how I would clean up this bit of a nightmare of code that we have already just from having our WebSocket code and blinking an LED. As we add motors and our sensors and vision processing, this file, if we left it in this sort of format, would get to become a nightmare very quickly. I'm also going to show you how I like to develop using Arduino. I like to develop using Visual Studio Code and then opening up this same file in Arduino and pushing the upload button. I'll show you that later in this video. For now, just know that I am using Visual Studio Code, but the Visual Studio Code Arduino extension was deprecated. There is a community effort to bring it back, but I actually find it easier just to code here and then upload my code using the Arduino IDE. So that is our goal, to basically take the code we already have and make it easier to read and easier to edit. As a reminder, this is the general global view of our code. We're going to have our global state for each module. Each module has some sort of update period, so how frequently do we need to update them? So a camera, we might only update and get information from 10 frames a second, whereas the compass, maybe we do that 50 frames a second. So these will all happen at different rates. Inside setup, we'll have our non-trivial global state initialization. And then inside of our loop, we'll try to do as little work as possible with just little short updates to each of our modules. So the camera module will just quickly say, hey, give me the next direction to turn. The compass module will say something like, hey, give me when the time comes, give me the correct heading to north. But let's start by showing you what I think the ideal version of this code would look like. So inside the current directory, I still have all the old TOIT code. I'm not going to delete that. And then I have our WebSocket heartbeat code from the last chapter. I'm going to start by just making an empty directory. And let's call it WebSocket heartbeat, and we'll call it the refactor. And inside this directory, I will create the Arduino file, so the INO file. It's standard to name your file, your main file in Arduino, the same name as your directory, though it doesn't have to be that way. And I should also mention there are a number of different ways to create that file. There's currently nothing in this, but let's take an imaginative look at what the sort of ideal version of this might look like. We'll have our global state. Actually, even on top of that, we'll have our includes. Our update timings, our setup function, and our loop function. What I'd really like to do is create some sort of WebSocket object here at the very top and have it sort of do both of the jobs all sort of encapsulated within one class. So let's imagine that. We have our WebSocket heartbeat. Let's call it the WebSocket heartbeater. That clearly doesn't exist yet. So just immediately, so I don't have to worry about these red squigglies being sort of obnoxious to see, let's create that file as well. So right next to the current file we're working on, I'll create a new file. And let's call it the WebSocket heartbeater. We'll call it a header file. That's what the .h extension is denoting. It could easily also be a C++ file. There's a lot of different ways we could arrange our code. It could also be an INO file. I'll try to motivate the reason why I have this a header file throughout the next couple of weeks. But I don't want to get too bogged down in the details on this first video. So let's move forward, assuming that we're going to have inside this file a class called WebSocket heartbeater. And for now, let's just make that empty. We have an empty class, and now I can include that here. And one little gotcha with C and C++ is if you have a file that's in the current directory or somewhere relative to the current file, you'll use quotes. For other libraries, so over here eventually, we'll do a pound include and include Wi-Fi.h. The brackets here denote to the preprocessor that it should look in sort of standard file locations for this Wi-Fi.h header file. And because I have a spell checker on, you might notice it says heartbeater is not a word. I'm just going to tell it that's okay. I'm going to consider that a word for the purposes of this project. Alright, so we have our global state. And our global state's actually going to take care of the update timings as well. So as part of this object, let's give it a member variable. This is probably a good reminder that I should disable Copilot for the purposes of this video. So to figure out what should go in this class, let's look what we had in the original version. We had our heartbeat interval and heartbeat last time. Those are strong candidates for being member variables inside here. Heartbeat interval is an unsigned long because the value returned by the millisecond is an unsigned long. This is because you would never expect an amount of time passed to be negative, and it might as well be the container that holds the largest valued integers. In addition to the interval, we also want the last time. Looking back at our main file here, we now have our WebSocket heartbeat interface. And its constructor will be called before main because we have this as an object here, it's not just a pointer. So what should we expect to do inside the setup function? Inside the setup function currently, we have some functionality that does belong to the WebSocket. So that would be all of this code here. I'm going to copy that, and we'll put it into the constructor for our WebSocket object. And I put it into the constructor, but actually much of this code is probably code that we want to delay running until we get to setup. So for example, we won't be able to do serial.print until after we've done serial.begin, which will happen at the beginning of setup. So now that I think about it, I should really pull that over first. And then we'll assume that we'll have to do something like call a setup function on that object. And the setup function is really where most of this code will belong. So what do we need to pass to this this newly defined setup function? Well, SSID is not defined inside here, and that's something we want the user to specify. Alright, that gets rid of a couple of errors. And it looks like we also don't have a WebSocket object defined in this new file. So jumping all the way back to the original file, that's this object here. This is defined globally, so this is a better candidate for something that we can put inside of our constructor of our new object. So I'll pull that over. And that's where we'll create WebSocket. So we have the WebSocket member variable, and it gets initialized in the constructor. So for this member variable, we need the port. And what is the type that WebSocket server takes? Well, it won't tell me that until I've included that library. So let's grab that over. And my auto formatter puts these in alphabetical order. That's why those two things were switched on the fly there. If we look at the constructor here, it looks like it takes a uint16 for the port. And this is a bit of C++ syntax that has me a little bit rusty. The error message here says no default constructor exists for WebSocket server. And you might be thinking to yourself, well, we're initializing this in a constructor, so surely this is when the WebSocket server constructor gets called. But actually, this is essentially overriding whatever the default constructor is for the WebSocket server. So a better way to do this same thing is inside of an initializer list. To make sure the first time that we are initializing the member variable WebSocket, we're doing so before the constructor is actually, the body of the constructor is actually called. A little bit strange syntax from C++, but you can think of this as code that runs before the body of the constructor. And it actually runs upon the very initial creation of the WebSocket heartbeater object. So now we have code that runs sort of at the global scope, and we have functionality that runs inside the setup function. The last bit that we'll have is something that runs inside the loop function. So let's have our template set up for that as well. And since we called setup inside setup, let's call a function loop inside loop. And I actually don't love the name loop because to me that implies that when I call loop, it's going to run a loop. So let's instead call this loop step, or loop iteration, maybe something better. I think I do like step better. Our complaint here is that we're not able to access these member functions, the member methods. And that's because by default in C++, anything you put into a class is going to be a private member variable or member method. So I can just set these all as public, and these should now be accessible. The first one is now just saying I didn't give enough arguments, which is true. So let's define our port. And there's nothing special about 8181. I know that ports in the 8000 range are usable for this sort of communication, and 181 is arbitrarily chosen because that's the course code for the class. And it looks like I have my own interface here backwards. The constructor is what takes the port, and setup takes the SSID. So I need to fix that. Alright, so now this file is going to be a lot easier to manage. We're essentially going to get the same functionality that we have in this large file, all nicely condensed down to something that should be easy to read in one screen worth of code. Jumping back over here, we don't yet have a loop step function. Let's add that, just a dummy function here, so that this error message will go away. Let's get to a good point here where we can actually test this code. So the last error message we need to figure out here is this WebSocket event function. So going back to our class from the last chapter, going back to our code from the last chapter, it's this function here that we need to bring over. And that does safely belong inside this WebSocket file. This is a really minor style change, but I don't actually like having a lot of code between the main, before the main class of a file and a header file. So I'm actually going to paste the function below our class. And when that happens, you'll see that my error message, actually I guess it only shows up on a compile, but it should be a problem that this function is declared underneath its use case here. And C and C++, one way around that is to create what's called a prototype, just to let the compiler know what are the types of this function. So that's why I'm putting this at the top here. And then the rest of this I can delete. Okay, so a quick description of this file again. A prototype for the WebSocket event function, our WebSocket heartbeater class, and then the actual definition of the WebSocket event function. And it's now complaining that WebSocket state doesn't exist, WebSocket disable doesn't exist. So those are two things that I need to bring over from the top of this file. This is small enough that I think it's worth defining in its entirety above our class. Technically, I could also define it inside the class. But this WebSocket state is going to be used more than just internally inside the class, so I'll leave it where it is here. And again, it won't make a big difference, but aesthetically I like to define my enums above functions and classes. The final complaint is that this WebSocket state global variable doesn't exist anywhere. In our file over here, we defined it at the top. So let's likewise define it at the top of this file. And this is something you won't see very often in good proper C code, which is a global variable defined at the top of a header file. There are a number of reasons to try to prevent your code having such a situation like this. A lot of those reasons go away when you're dealing with small software systems like we'll have for a microcontroller. So I'm actually perfectly comfortable having it defined here at the top of the file. It does mean we have to use a couple of edge tricks to make it so that this WebSocket state variable is available in multiple files, though. And looking through the other errors, our WebSocket is also not available inside the WebSocket event function. There are a number of ways we could go about making a WebSocket object available to the WebSocket event. None of them are particularly clean code. C++ just has some edge cases here that make it difficult to use this nicely. Probably the nicest way to write this code would be if the implementers of the WebSocket library allowed user data. So for example, passing in a pointer of user data here. That is not how the onEvent function works. And going to the definition of a WebSocket server and looking through their code, I was unable to find like a cleaner way to do this. So their public interface here just takes a port, an origin, and a protocol. And looking through for the, let's see, the name of the function was onEvent. It also just takes that callback function. So we are going to, in our code, not just have a global state here, but we're going to have a global WebSeat heartbeater. There are a number of different ways to do that. We could create what's called a singleton class, but I think a lot of that complexity is not necessary for the microcontroller environment that we're programming for. So instead what I'm going to do is just sort of globally bless a specific version of the WebSocket heartbeater. So underneath the definition for this class, I'm going to create a WebSocket heartbeater. And I can't think of any scenarios where we would want two of these objects anyway. So this is probably our cleanest way out of the mess of having this callback function. So now we can just access the WebSocket that's part of this globally defined WebSocket heartbeater class. Same thing here. And here. And it looks like that's cleaned up any error messages in this particular file. And now that I have a single defined WebSocket heartbeater, I think there's no good reason not to include this as just part of the interface that we have here. So now I'm initializing WebSocket state here as part of the constructor's initializer list as well. And just for reference, I could also just do so right here. But since we already have the initializer list, we might as well move it in line, as we did with initializing the WebSocket itself. We now have an error here. And the same error here. And in fixing a few errors, it looks like I have one final error message, which is that the port isn't defined outside of the constructor. So let's hold on to the port. And now looking at this, I'm realizing we haven't yet initialized the heartbeat interval or the heartbeat's last time. Heartbeat last time, and technically in C++ I should initialize these in the initializer list in the same way that they appear here. The interval should be passed in by the user. And the last time can be initialized to 0. And this line of code is now a bit long. And my auto formatter, I think that looks fairly reasonable, especially if I were to not have it at such a large font size. Alright, so we now have a functioning version of our WebSocket heartbeat interface. And all it's really in charge of is making sure that the WebSocket state is set to disabled whenever heartbeat messages are not coming in. In the next video, we'll look at moving over a lot of the LED functionality from the previous chapter.